Alright, this is Chapter 14, Solutions, and we're going to get through 14 to molarity. So, concentration. Concentration is the amount of solute in a given volume of solution, and it's most commonly expressed in molarity, and that's what we're going to focus on today, is this idea of molarity. We're going to really hone in on this idea of molarity. That's what I want to focus on. That's what we're going to do a lot of calculations with. So, your equation for molarity is, or the definition of molarity is the number of moles of solute per volume of solution. So what you're going to have to do is take the moles divided by the liters. So it's the solute divided by the liters of solution. So we just do, basically molarity is moles per liter. Now something that I didn't put in this slide here that you probably should know is that molarity is symbolized with a big capital M. So we'll use that a lot. So that's the symbol. And that's one of the reasons why we don't use M for anything else like mass. Well, mass we use little m, but we don't use that for moles. That we use it for molarity. So, alright, so now we're ready to get into the examples. Alright, we're going to do the first example for molarity, which is calculate the molarity of a solution prepared by dissolving 11.5 grams of solid NaOH in enough water to make a 1.50 liter solution. So we're going to use our big M equals moles over liter equation. So that's the equation we're going to use. Alright, and so what they gave us in this one, they gave us 11.5 grams of solid NaOH. Now if you notice from the equation that I just wrote down a minute ago, you have to have moles of NaOH. So the first thing we have to do is change that to moles. So I'm going to take, and I'm going to do a ratio, and I'm going to put my grams of NaOH on bottom. I'm kind of off camera there, sorry. My moles of NaOH would need to go on top. So I'm going to put that on top. Now, so then I would put a 1 with a mole, and then I'm going to need to calculate the grams of NaOH. So I'm going to go down here to some free space, and then I'm just going to calculate the molar mass. So I'd write NaOH, and then I have Na, I have O, I have H, each one of those. I have one of each, and then I'd find the mass of Na, O, and H. So I'm just going to do that real quickly. I have 22.990. I have 15.999. I have 1.0079. And so there's one of each of those. So it's just going to be the same. So I'm going to just write those down again, basically. So 22.990, 15.999, and 1.0079. So they're exactly the same. And then I'm going to add all of those up, and so I get 39.9969. And then of course I have to do sig figs. So in order to do sig figs, I'm going to have to round that to 39.997. And then that's what I'm going to use back up above for my grams of NaOH. So I'll just put that in, 39.997. And then now I'm ready to do the math here. So it's a division problem, 11.5 divided by 39.997. And then I'll have 3 sig figs with my answer. So that's going to be 0.288 moles of NaOH when I finish working that out. And so that's the number of moles that I have in that original 11.5 grams. And so now I'm going to use that back up in this equation for my moles to find the molarity. So I have 0.288 for my moles. And then I'm solving for molarity, so I'm going to put it in my M. And then that's going to be over my 1.50 liters, because that's what they gave me originally in the problem. And so now this is a straight out division problem. So I'm just going to divide those two numbers out. So I'm going to take 0.288 and divide it by 1.50, and so I get 0.192 as the molarity. Now, notice that the calculator answer actually is 0.192, and both of these numbers have 3 sig figs, and it's division, so my answer will also have 3 sig figs. So in this case, the calculator answer and the sig fig answer are exactly the same thing. So I'm just going to leave my answer, label it with a capital M, and then it's also going to be labeled with NaOH. So my actual answer for this one is 0.192 molarity NaOH, and that's how we do the first example problem. All right, we're going to do example 2, which is give the concentration of all the ions in 1 molar FeCl3. So to do this problem, the first thing we have to do is talk about what dissociation is. And dissociation is when you have an ionic compound and it breaks down into ions. And so we have FeCl3, for example, which is an ionic compound. And so when it breaks down into ions, it breaks down into Fe plus Cl. Now we got to find the charges, so we go back to the FeCl3, and notice that the chlorine has a 3, so that came from the Fe. So Fe has a 3 plus charge, and then chlorine we could look up on the periodic table, and so it has a 1 minus charge, or we could again go back to our original FeCl3 and notice that the Fe has a 1 down there, which came from the chlorine, and so chlorine has a 1 minus, and so there are the charges. And so if I zoom out here a little bit, you can see our dissociation equation. And so now that we have to balance this equation, and so we're going to balance it by putting some coefficients. We want both sides to be equal, and so notice that the chlorine has a 3 on it, so I'm going to put a big 3 in front of the chlorine in order to make those two sides equal. And so now the irons, though, are balanced because I have 1 iron and 1 iron. But the thing is, too, that you can look at, that if you don't just see the numbers, you can also look at the charges. Notice that the FeCl3 has no charge, and that the Fe has a 3 plus and the chlorine has a 1 minus. So, but if I put a 3 in front of the chlorine, that would make it so it has a 3 minus, and so 3 plus, 3 minus, those two sides would now be balanced. Now, the rest of the problem gives us the fact that FeCl3 is 1 molar, or we could say molar. And what they want you to find is the fact that what's the molarity, or how many molar is Fe3 plus and Cl1 minus. Well, the neat thing is that whether it be molar or moles, you can use mole ratios or molar ratios to get us to where we need to be. So we're going to do that. So you have 1 molar FeCl3, and so we're going to write down that, and then we're just going to do a ratio, and we're going to do just like we did mole ratios. We're going to use the coefficients. We're going to put our 1 mole of Fe, I meant to put not the 3 plus, that goes on top. We want to put the FeCl3 on bottom because that's what we're trying to get rid of. And we want to put our molar of Fe, I did it again, Fe3 plus on top because that's what we're trying to get. And then our numbers, of course, come from the coefficients in our original equation. So we go back up, we look, they're both 1s, so that's what we're going to use to get rid of or to get our final answer. And so notice they're all 1, so we multiply by 1, divide by 1, so it just so happens that our answer turns out to be 1 molar Fe3 plus. And of course, other problems are going to be more complicated than that. You'll have to divide, multiply, do your sig figs, just like we did with other mole ratios. But, you know, mole ratio, molar ratio, they're the same thing. Now, of course, this problem asks for us to find all the ions, so we need to do a second problem where we find the molar of chlorine ions. And so that's what we're going to do here. So I wrote down 1 mole, a molar of FeCl3, and I'm going to write a secondary ratio of putting 1 molar of FeCl3 on bottom, and I'm going to put that 1 molar of chlorine on top. And so now again, I do go back up to the equation. Now notice this time though that chlorine has a 3, and so I put that 3 there. And so this time though, it's going to work out to where chlorine ions have a 3 molar concentration. And so a little different than before because of the fact that it had a 3-to-1 ratio. And of course those ratios are going to change depending on what the coefficients are. So that's basically what the second example is like, just showing you how to use those molar ratios. Alright, we're going to do example 3. So example 3 is calculate the number of silver ions given this silver nitrate solution. So we're going to start out with dissociating silver nitrate, and so we have AgNO3, and so that breaks down into silver ions and nitrate ions just like that. And so notice that it's already balanced. We don't need to put any coefficients in front of the silver ions or the nitrate ions. And so now they gave us 25 milliliters of this silver nitrate, and then they also gave us 0.75 molar. Now, this is different from the last problem because notice that they didn't just give us the molarity of silver nitrate and ask for the molarity of silver ions. In fact, this time they're asking for what are the number of moles of silver ions. So what you're going to have to do is you're going to have to game plan this a little different. What we're going to have to do is we're going to have to find the moles of this and then do a mole ratio to get moles of this. So first step, use your big M equals moles over liters using the information for silver nitrate. So I have my molarity is 0.75. That's equal to, I'm going to find the moles because that's the whole purpose. They gave me my liters, but they gave it to me in milliliters, so I have to change that. I have 25 milliliters, so I have to change that to liters, so just divide that by 1,000. So that's the same thing as 0.025. Okay, and so now I have the number of moles. That's equal to moles is equal to, if I multiply those two, because this is a multiplication problem now. Okay, so I multiply those two numbers. So the number of moles is equal to 0.01875 is the, calculator answer. And then, so of course, we need to figure out the sig fig answer. So the sig fig answer would be 0.019 moles because they're both 2 sig figs, so our answer can only have 2 sig figs. All right. So that's the number of moles of, in this case, AgNO3. But I don't want moles of AgNO3. I want moles of silver ions. So I have to do one more step. So what I'm going to do is I'm going to come down here and I'm going to say, okay, I have 0.019 moles of AgNO3. And I'm going to do a mole ratio. And I'm going to put 1 mole of AgNO3 on bottom. And I'm going to put my 1 mole of Ag1 plus on top. Again, I got those from the equation. And then those are going to be equal to, and of course it's 1 to 1, so my given is my answer. And so my answer is just going to be, oops, close that. Go back to full screen. My answer is just going to be my given, which is going to be 0.019, and that's going to be moles of Ag, 1+. Okay, and so that's what you do if they don't give you just the molar to molar type situation. All right, now we're ready to do example 4. Example 4 takes us through the last part, which is if you have a basic big M equals moles over liter equation and they want you to get to grams. So they're giving us this potassium dichromate and they want us to figure out how many grams are produced basically. So they're giving us potassium chromate, and they're telling us that, so we're going to start off with our big M equals moles over liter equation, as always. And so in this case, they give us 1 liter of this solution, and so we have 1.00 liters. And they're giving us, in this case, they're giving us the concentration of the solution. So this is in this sense, and again, we're finding moles. Okay, and so what they want us to do here is they simply want us to take and they want us to find moles of this solution. So they want us to find grams. So we're going to have to find moles first. So we do our multiplication. So we come over here and we just say, okay, moles then is going to be equal to 0.2 times 1, which is just, of course, 0.2, and it has to have 3 sig figs, so 0, 0, keep those zeros for sig figs, moles of, and in this case, it's K2Cr2O7. And they were even really nice to us. Normally we'd have to calculate the molar mass of that mess, but in this case, they were even nice and said, hey, you have this, and we'll give you the molar mass. So that means all you have to do is take 0.200 mole of K2Cr2O7 and do a mole ratio. And we'll tell you that the molar mass of this mess is 294.2 grams of K2Cr2O7. And so all you have to do is multiply those two together. And so you multiply those, you get calculator answer 58.84 grams of K2Cr2O7. And sig figs, though, are given as only 3, so we're only allowed to have 3 with our answer, so 58.8 grams of K2Cr2O7. So that's basically what you do if they give you one thing and you want to find grams of that particular solution. So it looked a lot messier than what it was going to be, but it wasn't too bad.